So this is a problem from board exam. Yes, and we will try to solve this now. So a corner AB at the bottom of the wait can so a corner AB at the bottom of the cross section of the tank is shown in the figure. The tank is 2 meter wide into the plane of this paper. Given H1 is equals to 4.5, so this is 4.5 meter. H2 is equals to 3 meters, and angle is 45 degrees. Neglecting atmospheric pressure, evaluate the following. Okay, so the tank is 2 meter wide into the paper. So the width of this considered is 2 meter. We usually consider 1 meter width or 1 meter strip, but the problem states 2 meter strip that we will consider. So first is the total horizontal force on the corner plate AB. So this is the horizontal force FH. This will act on the center of gravity of the plane theoretically. Okay, so the formula for force horizontal is gamma H bar A. So we have water 9.81, and then H bar is from the top of the surface up until the middle point of the plane. So basically, H bar is equals to 4.5 plus 3 over 2 or 1.5. So H bar is equals to 6. So this is 6 meters. 6 meters. And then we have the area considered is basically this portion, this height, multiplied by the strip, which is 2 meter. So this is 3 times 2. 3 meters times 2 meters. Okay, force horizontal is equals to 353.16. The unit is kilonewton. Okay, so that's the answer. Letter D. Okay, the second question is the total vertical force on the corner of the plate. Total vertical force. So the vertical force is this. Force vertical. So first vertical formula is equals to gamma of the liquid times the volume of the liquid on the top of the plate. So this is the volume considered. Okay, so all the weight of the water on the top should concentrate in this force vertical. Okay, so solving, force vertical is equals to 9.81 kilonewton per meter cube multiplied by the volume. So say consider this is volume 1, and then the triangular is volume 2. Okay, so we write it here. Volume 1 is equals to 4.5. We should solve for this distance. We use tangent. Tangent of 45 equals to 3 over, say this is x. So x is equals to 3. So this is 3. So volume 1 is equals to 4.5 times 3 times 2, which is our strip considered. Okay, we have the volume 1. So we have 27. The unit of this is meter cube. So volume 2 is just equals to 1/2 of 3 times 3 times 2, which is equals to 9 meter cube. So the volume total is equals to 36. Yes, yes, 36 meter cube. Okay, we substitute the volume total here, which is 36 meter cube. Cancel the meter cube. You're only left with kilonewton. So the answer is 353.16 kilonewton. Okay, that's letter A. Okay, so our force vertical and force horizontal is just equals to each other. So the force resultant, or FR, is just equals to this force. If you have the force vertical and force horizontal, you will have the force resultant acting here on the plate. Okay, just Pythagorean theorem, tip to tail. So you can have this force resultant FH, force horizontal squared plus force vertical squared. So force resultant is equals to square root of 353.16 squared plus 353.16 squared. And you have the force resultant. Solving, you have 499.44 kilonewtons. Okay, so that's letter B. So there is another way in solving this using the textbook style in Lasagna solution. I'm just going to write it here how she solved it. Okay, so first she solved the force resultant right away. No? So the force resultant is just equals to gamma h bar a, but the area here is different. No? So the area considered is here, this area. Yes, the first area we considered here is this area. So we projected the plate in its horizontal face. No? So Fr is just equals to 9.81 kilonewton per meter cube. The h bar is still the same, which is 6 meters, and then the area is this. Okay, so solving for this side, um, let's call it h, or the hypotenuse, is equals to square root of 3 squared plus 3 squared. So h is equals to 3 square root of 2. Square root of 2. So the area now is 3 square root of 2 multiplied by the strip considered, which is 2 meters. So this is also in meters. So you are left with kilonewton. So you have force resultant is 499.44 kilonewton. So this is equals to the force resultant using this formula. Okay. So by solving the force vertical and force horizontal, you can solve it with trigo function because you already have your triangular loading. Okay. The angle considered is 45 degrees. Okay, so this is your force resultant, force vertical, and force horizontal. So basically, uh, when you solve for force vertical, you have a force resultant sine of theta, and then force horizontal is equal to force resultant cosine of theta. So substituting, you have, okay, so you have 353.15, and this also is 353.15. So that's it, no? So you have all the answers. This, and this. Okay, that's all. Thank you.